Hello, Bhargav.
Yes.
Yeah, do you want to share your screen?
Yeah. Should I just start right away or?
We'll start in 2-3 minutes, but maybe meanwhile you can just share your screen.
Okay. Can I
If
also
that,
share my? Can I also share my face? Or something?
yeah, yeah, yeah. Yeah.
Okay. Okay.
Hello, Bhargav.
Yes.
Yeah,
Yes. Hey.
share your screen.
Yeah. Should I just start right away or?
We'll start.
Okay. You are able to see my screen, right?
Yes, yes. Uh,
Yeah,
Bhargav,
I'm ready.
where is this, our attendee view? Yeah, yeah, it came. Yeah. So, Bhargav, maybe we'll get started.
Okay. For sure.
Yes.
So, is there anything that I have to do, or you can just?
Yeah, I think we can get started. Uh, so, uh, so maybe I'll just give you a very quick introduction.
Okay.
So, hello everyone. So this is our ninth online meetup. So hope you are taking care. Maybe we'll get started. One second. Yeah. Um, and yeah, so this one is going to be very short meetup. We have only two talks, Bhargav and Rajat. So maybe first we'll start with Bhargav start. Yeah, Bhargav, maybe we can get started.
Okay. So, you're all able to see my screen and see me, right? That's all
Yes.
set up, right?
Yes.
Okay. Awesome. Hey everyone. I'm Bhargav. Today, I want to spend some time quickly to introduce you to Rooks, which is a package that I've been developing for about 2 years now. It's 1,100 commits old. I've been spending a lot of time on it. And Rooks is a collection of React hooks that you can start using with your components. It's currently hosted at over here. So Ambargo 5/Rooks. So this is basically just a way for you to charge your components. There are many common use cases that we as developers face from in our daily lives. For example, building a drop down or building a slider, getting the size of the window, etc., which are very common and we use that quite often. And this package is an attempt to put a lot of these common use cases at one place so that you can just simply start importing them and start using them. So there are many hooks. There are hooks of various types. For example, there are some hooks which are lifecycle hooks, like did mount, did update, and there is will unmount as well. And there are some hooks that are for your forms, like there is use input and there is use toggle. Okay, and there are also some hooks that are utility based. For example, one of the newer ways of picking the size of an element is by using observers. So when an element resizes, you don't just simply grab it from window dot element dot size or element dot width, etc., because that causes some layout effects, layout thrashing, etc. So you would probably want to use an observer, and there are mutation observers. There is also bounding client, which is also a layer on top of mutation observer, so that you can get the dimensions of your element in a very performant way. Okay, so why did I build this hooks, and what was the motivation? So I think it was in 2018 November or December at the time when the React team introduced hooks, and I was hooked onto the screen. They were showing some wild stuff where you can just simply import a function and put it inside your component, and it'll behave completely differently to what you've ever seen before. And ever since then, I think a lot of patterns which were confusing me, which were very difficult for me to explain as to why you would even need to have that pattern. For example, there is render props pattern where you render a function as a child, or there is a higher order component pattern, or some patterns where you modify the child as you render. For example, you see these patterns in React tabs, right, where some specific components are rendered differently to make life easier. So all of these patterns, right, they arose because there was no great way of reusing your logic, and hooks were a tremendous way of solving that, and I was hooked onto them, right? So that day itself, I started this project, and I started with a few hooks that they released that day itself. So one is use input, and I'll just quickly start demoing that as well. Okay. So this is a small demo that I want to show today, what Rooks as a package can do. So one is use input. Use input is pretty common, but I'll just show. And you can start with an initial value, and you would be getting an input, and you can simply add your input onto the element. And as you type, the value as well as the on change prop is available for you to use. So you can just simply use this to send a form or whatever. Another useful hook when you're building forms is a toggle form. For example, you're dealing with a checkbox. Type equals checkbox, and there is checked. And you could use this hook, which is use toggle. And on change, I think you can do this, right? So basics. But this is where I started, and eventually I got to a point where I was building hooks that were more useful for components as well. For example, let us take a tabs input here, and a tabs input is just simply a list of a few buttons, and you want to just select it. So how would you do it without using your own custom hooks? You'd probably have a state, and you want to take a list as a as an argument and just iterate over that. And when a tab is clicked, you want to toggle that. So this is a pretty common use case. So for that, I built a hook called use selectable list. Use selectable list. And the nice thing with Rooks is that this is built with TypeScript, and it has tremendous Visual Studio's IntelliSense support. It gives you all the props that it expects. So it expects a list and it's an array, and I want to pass in tabs, and I can send it an initial index. Initially, I want it to be at 0. And what it returns is, it returns in the first argument, the first value in that array is an array. We don't need that for this example, but it contains the index and the current selected value. And you can also now get the ones that you really care about, how to toggle it and how to check if some button is matched. So one such handler is toggle selection, the other one is match selection. So I can use toggle selection. So when I click on this, I want to toggle it. So on click. So there is another issue with event handlers, because a lot of these times we generally have to do this, right? We have to pass a function. So that was annoying to me. So I made this a slightly higher order function. So you just have to pass and toggle selection with the index. You can either toggle the selection based on index, or you can toggle this based on the value. So let us try with value first. So I want the value to be changed to tab. Okay, and I also need to get whether this, wait, let me just print this so you can see what's going on. There is index and there is value. Okay, so initially my account is selected. We are not able to see that it is selected. Let's quickly fix that and use match selection. So a tab is selected when match selection for that tab returns true. So const is selected if match selection of that is true. Of value is tab. And instead of just simply putting in class name as tab, if is selected, then tab, otherwise tab and selected. Oops, 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 oops. Anyway, so now that is set up, I can now quickly click on the buttons, and the tab behavior is set. All I had to do was simply use the use selectable list. I didn't even need this. I just put them for just to show you what's going on in the console. But so that is the idea, right? When you're building a custom hook, you want to make sure it is as easy to use as possible. And when you're building a tabs component or a dropdown, what do you really care about? You care about toggling it, and you want to check if that element is selected or not. So building these kind of utilities is helpful when you're using a package like Rooks. Having your hooks that are ready to use into your logic is very helpful, I feel, personally, in my opinion. Okay, and one other example that I want to show is this dropdown. Again, dropdowns are something that you build very regularly. So again, we are trying to select one item from a list of items. We have already seen how to do that. We can also select multiple items if we wanted. So we can use a hook called multi-selectable list. So here again, the name is a dead giveaway. It's like I built hooks only for dropdowns. But trust me, there are many hooks that you can grab from Rooks and start using it for your components. But dropdowns just works very well with Rooks. So again, it's a multi-selectable list. I want to be able to select multiple values. And again, it takes a list as argument. So fruits. And it takes an initial array. So I want my initial selected values to be just 0. Okay. And again, I don't care about the first argument again here, but I can grab the controls. And in this controls, I will get update selections and match selection. And I can use this to check whether a value is selected or not. So I have a simple list item here. And if it is selected, I'll just show this. Okay. So is selected, or match selection of, let's use index this time. So where is it? Okay, fruit and index. and I want to check if this index is selected. If it is matched, then I want to show this tick mark. So because Apple was selected, it got checked. So now when I click on one of these list items, I want to toggle it. So on click, pretty sure toggle is also there. Yep, there it is. Toggle selection of index. Right. And finally, over here, it would probably be helpful if I can just simply list all the fruits that were selected. So I can, in this case, this is handy. So I just want the selected fruits. And here, if selected fruits dot length, then dot join. Okay. So this way, you can also use use multi-selected list for a drop down to check multiple values, right? But there is again a problem with this dropdown. It is not closing, it is not opening, etc. Let's try to fix that with hooks. So first, we'll use a toggle hook to check if the dropdown is open. Toggle dropdown open equals use toggle, and initially it's false. So I'm going to use if dropdown is open, only then show the lists. So I simply have to close this. Let's drop down. Okay, so the dropdown is initially closed. Now here, all I have to do is on click, I want to toggle the dropdowns open status visibility. So now the dropdown is opening and closing fine. Another problem is that this dropdown, when I click on it, I also probably want to close it. We'll fix that eventually, but at least the bare minimum is that when I click outside, it should close. So there is a super handy hook for this behavior, and this is called use outside click ref. And what this does is it returns you a ref, and whenever you click outside that that element which is represented by the ref, it will call you a function. So in this case, I want to call the toggle dropdown open function. I don't want to call this always. I want to only do this when the dropdown is open. So it also takes in an argument called when. So there is this when here, and it's a boolean. So this will only be active when this dropdown is open. So I'll just put that here. And actually, let me put a console log as well. Closing. And now I can simply take this ref and give it to, which one is it? This. Okay, so now I click on it and I click outside, it closes. You can check the logs. So now I'm clicking outside, nothing is happening. But now if I open the dropdown and click outside, it closes. This is, I think, a super handy hook that you can use with your models, your dropdowns, your toast, notification, etc. Very handy. The last hook that I probably want to show here is the use key ref, or use key, in fact. So again, it's probably useful if you want to close the dropdown when you click on escape, right? So that's also pretty useful. So I can use key. And when I click on when I press escape, I want to toggle the dropdown open state. I want to call this function. And again, I want to just do that when dropdown is open. So this when argument is optional. You can choose to pass it or not. If you don't pass it, it defaults to true. So this use key hook, it binds onto the window, onto the document. So you can also use key ref if you want to, just bind inputs on perhaps the on an element. If you want to only listen the keyboard events on a particular element, you can use key ref. It will return your ref, and you can pass the ref to whichever element that you want to track. Okay, so let's see if that works. So I'm going to open the drop down and press escape, it's closing, right? So use key is again pretty handy for when you're dealing with models again. So the idea behind Rooks is the same. I want to make sure that building the complex stuff like models and dropdowns that we do so often. Every website has a model, every website has a dropdown. And when you're working with these complex workflows, it's handy if you have a simple hook that you can simply uh, add to your components. I just want to show use key ref if possible. Mm. Oh yeah, there's one other hook that I want to show. Sorry, there's so sometimes what happens is that you have, for example, let us say, um, for some reason you want to just log, a click when someone clicks outside this dropdown for whatever reason, just uh, for example's sake. And a lot of times this happens. You have multiple refs that are corresponding that you want to correspond to the same element. You are tracking the ref of the same element, but you're trying to use it with multiple behaviors. So use outside click ref is just an example, but you'll get the idea. So we'll log outside click, and maybe. So what happens is that you have two refs here. There is ref one and ref two, and you have to pass the same ref to this particular div. And we know that React elements only accept one ref. So there is a handy hook here called use merge refs that will merge multiple refs together. You can pass in any number of refs that you want, and it returns a single ref. And you can just simply pass that to your dropdown here. Okay, so as you can see, both behaviors are working, and we are able to merge a single ref. We are able to create a single ref out of multiple refs which have been joined together. So this use merge refs is a pretty interesting hook because it breaks the rules of refs. It uses a for loop inside it, but the idea behind refs is the same. As long as you maintain the number of hooks inside a component, you're not breaking any rules. But yeah, generally you don't see for loops and if else inside a hook, but as long as you do them carefully, you should be fine. So that's about, just to give you an idea about what Rooks is all about. It's just a collection of multiple hooks that you can start using um, into your projects. And a lot of these hooks are also server rendered capable. So they work perfectly fine on the server environment as well. There are also some hooks like use timeout and use interval, which are pretty difficult to build with hooks unless you understand closures and how stale state happens in closures. So I spent a lot of time on this, and I'm sure you're going to love it and use it with your websites. Um, the last thing that I want to tell is that to install Rooks, you can simply install the whole package, like so. You can install yarn install Rooks or something, or if you only want a particular hook, you can also do that. All of these hooks are available on yarn as independent packages. But even if you install the entire package, your bundler will only use the ones that you're using. So that way your packages won't be bloated or anything, because all of these modules are ESM ready. Um, and I think that's about it. So there are a lot of people who contributed to this repo, and I'm very thankful for them. And yeah, I hope that you're able to try out Rooks in your um, in your, in your work, and let me know if you have any suggestions. So issues and pull requests are open. Thank you very much. Thanks, Kiran.
Yeah, thanks, Bhargav. Nice package. I haven't tried it out, but yeah, I'll try it out now.
Thank you.
Yeah.
Yes.
So
Yes. Mhm.
yeah, if you have any questions, you can ask now.
I shared the both the URLs on in the chat.
Yeah.
Hi, Kiran.
Hello.
Yeah, this is Kayum.
Yeah. Hi.
Yeah, is that the link which we covered till now? GitHub link you shared in chat, right?
Yeah.
Yeah, actually, I joined a bit late from the.
Oh.
I didn't catch up.
Okay. Bhargav.
Yes.
Yeah, yeah. So yeah, we recorded this talk, so we'll be sharing
Okay.
this talk as well. So in case you
Yes.
missed the talk, you can follow the talk, and maybe you can also reach out to Bhargav if you have any questions.
For sure.
Yeah,
Uh, yeah. Then do check out this library Rooks, and if you have any questions or if you come across new use cases, maybe you can reach out to Bhargav and also contribute to the library. Uh, Yeah, if you don't have any questions, then we'll move to the second talk. Um, Rajat,
Yep,
yeah, you can take over.
sure.
yeah. One more question here.
Yeah.
Wh- Where can we find this recording link through mail or?
Uh, uh, so you can find it in our YouTube channel. Maybe we'll post it. Uh,
Okay, okay.
okay.
Yeah, got it.
Yeah.
Yep, so I'll start. Yeah.
Yeah, I posted the link for the YouTube channel. Sorry. Everyone. Yeah, for the YouTube channel. And you can find this meetups and all our previous meetup talks in that YouTube channel. Great. Yeah, Rajat, you can take over.
Sure. Hey guys, so this talk is about advanced TypeScript. So these are just the learning notes, my personal learning notes that I've been doing about a few advanced topics in TypeScript. So my name is Rajat, and this is a pretty old photo of mine. Uh, I have been working as a front-end engineering manager at Certa, and you can find all of my work and post about TypeScript and React.js at my GitHub and Twitter. If you have any question, feel free to reach out. We'll quickly dive into the agenda. So we'll talk about three things today. First is the type guards. So type guards is a feature of TypeScript that lets you leverage type checking at runtime. So TypeScript is just compile time, but type guards lets you leverage some of the features of TypeScript at runtime. Then we'll talk about writing test cases for your types. So this is something that not a lot of people are doing right now, but we'll talk about why should we do it and how can we do it very easily without wasting a lot of time. And lastly, we'll talk about idiot proof switch statement. So these are just switch statement that gives you error in TypeScript if you forgot to handle a particular case. Instead of breaking at runtime, it gives you error at the compile time. So we'll start with type guards. So the TypeScript doc define type guards as some expression that performs a runtime check that guarantees types in some scope. So these are the expressions that the main term here is the runtime check, and that guarantees the type in some scope. So let's say you have a variable defined of data type any. So if you define any variable as any, you lose all of the type checking mechanism of TypeScript and you fall back to JavaScript. And so that is a very bad thing. But let's say you have a variable that has data type any, and if you do something like if type of data is equals to number, TypeScript will automatically infer the type of data inside this scope as number. So even though the statement will run at runtime, the data the data type of data variable is inferred as number on the compile time in this particular scope. So this is a particular type of type guard, the first class type guard that TypeScript provides. Type guard basically lets you narrow down a type of a data. So initially the data type was any, so it was a blanket data type. It could have been any data. And then inside this particular scope, by using type guard, type of is a type guard that TypeScript provides. You actually narrowed it down to a number data type. if we look at a actual use case, so let's say you're making an API call, you're making a get API call to fetch a count of a resource from the server. By using Axios, you can simply do axios.get your API URL, and then you'll access the .data variable from the response. .data member of the response is the part where actually the response returned from the server resides. So you can actually access that, and this response is of type any because your client doesn't know the data type returned from the server. So it actually takes it as any. This is our user defined type guard. Assert is number, which actually asserts is as number. And so in line number 7, the response has data type as any because it's a third party data type and we don't know what the data type of it will be. But in line number 12, TypeScript infer this data type, its data type as number at compile time. So this function is a user defined data type guard, which actually makes this difference from line number 7 of any data to line number 12 of data type number. How this actually matters to us is without using a type guard, the function signature of fetch count was a function that takes nothing but returns a promise that resolves to any, which is a bad sign and which could lead to a bunch of errors inside your code. After using this assert is number type guard, this function signature converts into a function that takes nothing but resolves to a promise that resolves to number. So instead of having a blanket data type, you narrow down the data type to a number without defining an explicit function signature to your fetch count function. So this is the power of type guards that lets you actually narrow down your data type from any to a specific data type. We can do this in a more complex manner also. So let's say you're making an API call to get a list of employees, and an employee is your custom data type, which has these bunch of strings. So you can create a type guard called assert is employee array. So initially the data returned from the API will be of type any. And if you run this type guard on your response from the API, the inferred type of this response will become an employee array. So how do we actually write these type guards? So we'll see an implementation of assert is employee array type guard. So I have this basic code written. So this is a function that takes nothing but resolves to a promise of any. And this is an employee data type. This is my type guard. Assert is employee type guard. We're going to write the implementation of this. So before writing the implementation, let's write a function that actually checks if a data is of type employee. So we'll write a function called is employee that takes data of type any.
Rajat,
Yeah.
we can see only your slides, not your code.
You can't see the code right now?
No.
Okay.
Maybe you shared only your browser window. Maybe you have to share the entire window. When you
Stop, actually, it's the same setup that I started with initially.
okay. Maybe can you stop and reshare your screen, entire screen? Yeah.
I'll do that. Is it with?
No.
Wait,
Can you share your screen?
yeah, I'll start. Can you see it now?
Yeah, now we can see your screen. Can you switch to your slides also once?
I'll try. Actually, I moved on to the full screen view. That's why it might have been.
Okay.
I'll just make it screen. Can you see the slides now?
No, we are seeing only your code. Okay, maybe when you are sharing, share your entire screen, not just one particular window.
Okay.
When you click on the yes, yes,
Slides code
yes. Can you switch to code?
or switch to code.
No, we are seeing only our.
Share the complete screen. Give me a second.
Yeah, when you click on the share screen, right? Choose the entire desktop.
Got it. Yep.
Can you try?
Yeah, I'm trying. Just a second. Just make it full screen. Share screen. Can you see the code now?
Yes,
And the slides?
yes, yes. Perfect.
Yeah. So I'll just rewind back 2 minutes. So I have this function called get employees that has this function signature of it takes it takes nothing as an input but returns a promise that resolves to any. And we have a data type, a user defined type called employee, which has these following members: ID, employee name, and etc. etc. So what we are going to do is we're going to write assert is employee array type guard, which will actually help us narrow down the data type of this function. So right now it resolves to any, it should resolve to employee data type, employee array to be specific. So we'll write a is employee function that takes any data of type any. So it takes data of type any because it takes the response returned from the API as an input and we don't know its data type. So we specify it as any and we return, we actually define its data type as data is employee. And we can use the type of type guard and we can use it to compose and create a custom user defined type guard. So if data dot id is string and type of data dot employee name is string and type of data dot is, I'll just copy it from here, is also string. And let's just remove these two keys to make it a bit faster. So this is employee is a function that takes data of type any because it takes the response from the API and asserts your data type or asserts, or more specifically type guard your data to be of type employee. Now let's write this function assert is employee array. So instead of receiving one employee from the API, we are just receiving an array of employees. So we'll do this. We'll first define its return type, asserts data is employee. So what this return type means is if the data employee array, if the data that the function is taking as input is not of type employee array, it will throw an error. If it's not an array, will throw an error. And we can write user-friendly error messages, expected array, but received JSON.stringify, and we can stringify the data to provide better messages. And then we'll check if it is if every member of the data is of type employee using is employee function. If data dot sum item is employee, and we'll check the negative of his employee item. We'll throw an error, throw type error saying expected employee. We were expecting each element of the data array to be of type employee, but we received we can again json.stringify and print this. So once we have done this, if we now check the data type of this get employee function, you can see it has been narrowed down to employee array. Employee array. Initially, it was promise that resolves to any. Now it's a promise that resolves to an employee array. And this is possible at runtime also, because if you receive an array, if you receive a data which is not of type employee array, it will simply throw an error. You can catch these error and send it to your Sentry or something, that your error logging mechanism that you have. And this will provide you type safety at runtime. You can make it more generic by using this. So what we're doing here is we are checking if assert is employee array. We are checking if every data is of type employee array. We can make it more generic to make the data type as a generic argument. So we can write a function called assert is type array. It could be an array of employee type. It could be an array of number. It could be an array of string. It could be an array of any custom data type that you want. And you can use this utility as a custom utility across your whole code base. So it again takes a data of type any. And now as a second argument, it takes a check that it has to run. That check is a function that takes data of type any and return data is t. It is similar to the previous function that we wrote. It's written here also. It has the same signature as is employee. So is employee is a function that takes data of type any and return data is employee. And we are doing the same here, but instead of specifically specifying the data type, we are using TypeScript's generics so that we can use it for any function that we want, any type that we want. And now we can do exactly the same things. Since we are checking for an array, the first check has to be an array. Array.isArray data. If it's not, we'll again throw error. We can copy the same error from here. And now, instead of doing specific data checks, we can use our check function. And then we can throw the same error. And instead of employee here, you can write a generic message, unexpected data type received. And now you can define its return type also. Asserts data is t array. So if you see the signature of this is the same function as we wrote before, but instead of working on is employee or employee type specifically, it works on a generic type t. So it takes data and check. A check is again a function that has the same function signature as is employee. Now you can use it to create any specific function. Let me remove this. So now I've created assert is employee by passing the data, and the value of check function becomes is employee function that we have defined on top. And you can use it to create assert is number array, assert is string array, by passing a different check functions every time that you're calling it. So this becomes a general utility for type guards. I'll just move on to the slide where we have. So there are other examples of type guards that TypeScript provides as a first class member. Type of, we have already seen type of. So when we say type, so let's say we have a function that takes a value argument that could be of type function, date, and number array. So this is a very big blanket set of data types. And if you want to actually perform some functions on it inside your function from line number 2 to 15, we have to narrow down the types. And that's where your type guards come into role. So you can say type of value is equals to function. So inside the scope from line number 2 to line number 5, the value will always be of type function. You can even use instance of. So when I say value instance of date, inside the scope from line number 7 to 10, value will always be of data type date. You can even use array.isArray. So when I say array.isArray on the value input that I'm receiving from this function, the data type inferred will be automatically of type number array, because this is from the possible data types of the input that you have defined earlier. So type guard is just a way to narrow down a bigger set of data types to a smaller set of data type, or to a very specific data type that lets you actually perform functions on that data. So when I say this is date, inside the values of type date inside line number 7 to 10, I can actually run every possible function that is possible on date on the value without TypeScript complaining about it. But if I do the same thing on line number 2 or above the line number 2, TypeScript will complain about it, because it could be of type function also and of number array also. We can't run date functions on function or on a general function or a number or an array of numbers. The next thing that we are going to talk about is tests for your types. Why do we want to write tests for your types? Types are also code that actually change over time. So you have generally in a very large code base, you have a file where you declare most of your generic types, and you use them across your whole code base. And as and when your business requirement changes, you keep adding keys to the data types. You're changing the data type of any member inside that data type, or you keep removing keys, or you keep moving keys optional or something like that. And you have to make sure that the previous code and the code that you'll be writing further will not break according to that, your changes in the types. That's why you need tests for your types. So how do we actually write tests for your types? We can't use jest. Why can't we use jest? Because jest actually runs on your compiled code. Jest actually runs on your JavaScript code, which gets compiled from TypeScript. So it loses all of the type information. You can't write tests for your types using jest. So we'll be using a library called TSG to write tests for your types. So I already have a small code snippet here that is a React component called select. So it's a simple select bar drop down option. I've defined the props of it. So it takes a prop called options, which is an array of value and label. Value could be string actually, and label can be React node or a string. So what I'll do is I'll quickly build this thing. I'll clear it. Yarn build. Yarn build just simply runs the types tsc command. Okay, it gives me, I just think I didn't save this file. Okay, let's rerun this. Yeah. So it runs a tsc, the yarn build command runs a tsc command that generates, compiles all of my TypeScript into JavaScript and move this, and the compiled code gets saved inside this dist directory. It has the type definitions as well as the compiled JavaScript code and the source maps. So what we are going to do is we are going to create a new directory called test-types. This will contain all of the test cases for our types, and create a file called index.d.ts. So this is the bare minimum requirement for TSG library that runs your test cases. So it expects a index.t.ts inside the folder where you're running all of your test cases. And this is where it will import all of your types that you want to write test cases for. So I'll simply do export star from test. So I'll export every type that has been exported inside test, and I'll just re-export them inside index.d.ts. And I'll write, I'll create a file that I will write in my test cases in. So index.test-d.ts. It's just a naming convention. So every file that you're writing that has test cases, you can use this format to write create file names. I'll simply import the types that I want to write test cases for. Option, let's write the test cases for option. From my TSG library, there are two helpful utilities that actually lets you write test cases: expect assignable and expect not assignable. And then you can simply write test cases like expect assignable to label, label and value. So label is of type string and value is of type string. It does not give you an error here because your option actually is assignable to this type. Your value could be a string and a label could also be a string. When I write it like this, let's write a test case that actually fails. So I say label is of 1 and value again string. Sorry, I'll write label as label and value as 1. Since value could only be string and we are providing it as a number here, it gives you an error saying the number is not assignable to type string. So this is the error that this is how you write test cases for your types. How do we actually run it on a CI platform? So you can actually, so I have a command in my package JSON, tests:types. I can run this command directly. Yarn test:types, and I'll provide the name of the directory that contains all of my test cases. And it gives me an error saying type number is not assignable to type string, which is fine because we were intentionally trying to write a failing test case. Here we can use expect not assignable, which means option type could not be assigned to this. So we're writing a negative test case here. And if we rerun it, now it works fine. So this is how you can write test cases for your types. So the idea is keep writing test cases iteratively for your types. So as and when your type changes, keep adding test cases. If you add a new member inside your type, add a test case for that member. If you make a member optional by using the um, by using question mark, write a test case for that actually expects it to be an optional member. Just keep doing this iteratively. Keep improving your test cases iteratively. Moving on to the slides. Yeah. So the final thing that I want to talk about is idiot-proof switch cases. So switches are generally considered as anti-pattern. People will recommend you to not use switch cases, but there are actual valid use cases for switch, where you have where you want to make a huge if else if condition. So sorry. So in our current code base, we render field on a basis of field type. So we have generic forms, we render field on the basis of field type, and we have like 30, 35 field types of field types. So we actually use a huge switch case for that. The problem here is, how do we actually make sure that we add a case for every type that we want to handle? How do we not forget to handle a case in a switch case? So let's see the problem in code. So you have the smart switch. I'll just close everything. Yep. So what it does is, you have a type called field type, which could be of a single select or checkbox. And you have this function called get field component string, which takes field type as an input. And depending on the field type, it will return the name of the component that you want to render. So if your field type is single select, you want to render the select component. If your field is checkbox, you want to render the checkbox component. Now, and if it goes into default, which it should never, it will throw a runtime error, which is a perfectly valid thing to write. Idea is for this to never go inside the default, so it will never throw an error. If there is some error in your API which returns a field type that the front end is not aware of, it should throw an error, and that is a perfectly expected thing. Now what happens is, a new developer comes in and he's asked to add a new field type. He simply comes up and adds this field type called multi-select, and he forgets to handle a case inside this. The only place where you'll actually see an error happening is at the runtime in the browser, when your users are actually using your application. There is no compile time warning or error for this. You can actually leverage TypeScript to do that, to handle it and give you compile time warnings by simply subclassing your error. So we'll create a new error called unreachable with the proper spelling. Unreachable error, which extends the error class. And inside this constructor, instead of taking just one argument string, it will take two arguments, val of type never and message of type string. I'll come back to this first argument, but this is actually what enables us to do idiot proof switch in the first place. And we'll call super with any string that we want. So unreachable code reached, and we can use the message. We can even print the message that was provided inside this code. And now we can just simply replace this with this error that we are writing here. But before replacing, let's quickly see one very interesting thing. If I see the inferred type of field type here, after removing this case, the inferred type of field type is never. It's never because field type could be of could have two possible values, single select and checkbox, which you have already handled. And if still the code has reached the default clause, that means the type of this is never, which means it could be nothing. Never means nothing. But when I go ahead and add multi-select, the type becomes multi-select. It becomes multi-select because we have already handled single select and checkbox. Now, that is the thing that we are going to leverage, and we are going to remove this thing to right here and field type. So initially it works, everything is working fine. It's expecting unreachable error, expects never. In the first argument, it's getting never because we've handled both of the types in the first two cases. And now if we add multi-select and we don't add a case here, TypeScript will start complaining because now the field type is multi-select and it was expecting never. So this is how you can actually write a idiot proof switch case, which forces you to handle all of the cases at compile time. So thank you. That was it. And if you have any question, feel free to reach out my Twitter or GitHub. You'll find all of this code at GitHub. I'll share the repository link also in some time.
Nice talk, Rajat.
Thank you.
So if you have any questions, you can ask now. So I think Rajat, this is the first time I'm hearing people writing tests for types. How common is that? How often people do that?
It's uh, it's very rare that people do that, but we have in our current code base, we have actually starting to feel the need of all this.
Okay.
Yeah.
Is it because okay? Is it because you didn't have much confidence on the TypeScript or the way we write TypeScript code?
So actually what started happening is we have a separate, we have a monorepo code base and we have a separate repository for all of our types. And we started using types for like a single type at multiple places.
Yes.
And as the business requirements started changing, we started changing our types and nothing broke.
Okay.
But when we start writing new code on the basis of these older types, things
Yeah.
started breaking because of the loose types.
Yes, yes.
So that's why we started realizing that we have to write test cases for that. And yeah, that's where it is.
Okay, okay, got it.
Yeah.
And is there some sort of coverage? Do you know how for this TypeScript test? How many types you covered, how many types you haven't covered, something like that.
So TSD provides a coverage tool also that you can use to write test your coverage also from that particular repository where you have all of the types.
Okay.
Yeah. There is another tool called DSLint, but
Okay.
it has a very complex setup. But it provides a lot of, so what DSLint provides you is you can write test cases on the basis of different TypeScript versions. So if my TypeScript works, if my types work for TypeScript version 4, 3, 2, 1,
Yeah.
you can run your test cases for multiple TypeScript versions. TSD does not provide that, and that was not a requirement, so it's fine.
Okay, got it. Okay, then I think looks like that's all the questions we have. Yeah, thanks everyone for joining. Thanks to Bhargav and Rajat for sharing your experience. Thanks.
Thank you,
Maybe
guys.
we'll join in the next meetup, most probably in January then. Hi Rajat, you have one question.
Yeah. So that's a very good question, actually. So the question is, how much type guards differ from explicit typecasting? So explicit typecasting using the as operator is something that you should never do. Is something that you should never do because TypeScript will never complain if you're casting it in an incorrect way. So if you're casting a data type, a data that you're receiving from the server, and it has a and the data changes over time. But if you're still casting to a particular data type that you're expecting it on the client, TypeScript will not complain. Your code will break at the runtime. But in case of type guards, since you're actually throwing errors manually, you will always see the errors at the you will see the errors at the runtime, but you can again handle it using Sentry. But that will be a very explicit error that you know where the things are failing before reaching to the main component code. So in general, never use typecasting, the AS typecasting, the AS operator typecasting. That will lead to a lot of error. bugs in your code that you will find at runtime, not at compile time.
But type guards also, I think you said, the code you wrote for the type guards,
Mhm.
that will also be there, that will also do those checks in the runtime, right?
Correct. But that will throw an error, will throw a very explicit error, and at the position where you know, because you have written those errors.
Yes,
But
yes.
the typecasting, the error caused by typecasting will be at places, could be at any place where you're actually accessing the keys from
Yes,
that
yes.
object. So that is very risky and difficult to debug.
Yeah, I get the benefit of, the type checking, the added advantage of type checking, but it also increases the code size, right? The type guards code increases the code size, right?
Correct. It does. It does. Yeah.
Yeah, especially if you have like too many APIs, if you are doing data checks for all the data, it might get tricky over time. I believe so.
Yeah. So that's why we start creating. So there are multiple libraries out there that actually provides these generates your type guards automatically from JSONs.
Haha.
So
Okay.
that is something that you can do declaratively. So that reduces a lot of code.
Okay. Okay. Like maybe you weren't using GraphQL, right? Uh,
Yeah.
yeah.
Yeah. We,
Maybe if you are using GraphQL, then type guards, at least for the APIs, you won't be needing, right?
correct.
Yeah. Yeah. Because if the data is incorrect, the GraphQL server itself will send you those errors instead of you doing those checks on the front end.
Exactly.
Yeah,
Yeah.
makes sense. Um, okay,
Hello.
we have one more question, Rajat.
Mhm.
I will just copy paste. It's in YouTube, so I'll paste it here.
Sure.
Okay. How do we handle variables that are private in test cases using Jasmine or Jest?
So when you're actually writing test cases in Jasmine or Jest, you're actually writing test cases on your JavaScript, your compiled JavaScript. So there are no private variables in that case.
Yeah. Also, we should not write test cases for private variables.
Exactly. Right.
So the agenda for the next meetup is not ready in the sense, we are mostly open platform in the sense, anyone can propose talks according to their interest. So there is no fixed agenda. So yeah, so we'll announce our next meetup and, open the CFP process so people can uh, propose the talks. Yeah, people who join the meetup, right? If you have something interesting to share with the audience, feel free to reach out to us. Sure. So that's all then. Maybe we'll end the session. Uh, Feel free to reach us if you have something interesting to share to our audience, and maybe we can announce the next meetup as well. Yeah, see you in the next event then. Bye, everyone.
Bye. Thank you.
Yeah, thanks, Rajat.
Thank you.
Meet